Hi everyone, once again welcome back to our class. Now last class we were discussed about the time of flight, time of ascent, time of descent, the velocity of the projectile body, the velocity at half of the maximum height, the velocity of the body at 3/4 of the maximum height. Now we are discussed about the relation between time of flight and maximum height. Okay, now here show that the two equations here. See here, first of all ikkada chudandi, the time taken by vertical projected up body to reach 3/4 of maximum height. 3/4 of maximum height is equal to TA by here 2, TA by 2. Next second case here, the velocity up takes a time t is equal to TA into TA, nothing but here time of flight, time of ascent into 1 minus 1 by root 2 to reach half of maximum height. First of all, the maximum height formula and time of flight, time of ascent, time of descent, just to listen one recall here. Maximum height formula here, maximum height is equal to u square by 2g. Time of ascent is equal to here, time of descent is equal to just to u by g. Time of flight is equal to ta plus here td is equal to 2u by g. These are last class we were discussing about these formulas. Maximum height v square by 2g, time of ascent is equal to time of descent is equal to u by g, time of flight is equal to 2a plus 2b 2d is equal to 2u by g. Next, the velocity at the half of the maximum height. Velocity at the half of the maximum height, that means here simply this one, this is a height is here nothing but here total height. This is a total height. Okay, half of the maximum height means h by 2. Okay, h by 2. Its velocity here v is equal to u by root 2. Root by half of the maximum height velocity v is equal to u by root 2 and 3/4 of the half of the maximum height here 3/4. This is a just half of the maximum height. This point here 3/4 for example here height. Okay, here velocity is equal to u by just to here 2, u by 2. These formulas now using in this explanation. Okay, first of all, time taken by vertically projected up body to reach 3/4 of maximum height. Maximum height is equal to TA by 2. So time of ascent by 2, time half of the time of ascent. Now here clearly, first of all, this is the ground for example. Okay, the body projected vertically up with the initial velocity u, with the initial velocity here u. Okay, u at the point is this point o is a midpoint of the maximum height, midpoint of the maximum, that means half of the maximum height. So the height of the this point here, total height here, this is a h. Here half of the maximum height nothing but here this is a 2. The velocity of the projected body here to o point, that means here v is equal to u by root 2. Next, here 3/4 of the maximum height, that means here this point for example o prime is here, just example o prime from the ground here 3/4 h. This is a 3/4 of maximum height. So at point o prime is equal to here velocity is equal to at point o prime just here this one u by just 2, u by 2. Okay, now find out the time taken to reach the body 3/4 of the maximum height. Here t is equal to TA by 2. We prove the t is equal to here TA by 2. Now here initial velocity of this point of projection u, the point the body to reach the o prime here velocity just here this velocity v is equal to u by 2. V is equal to here u by 2. V nothing but to the velocity of the projectile at point O prime. this point here 3/4 of the maximum height. Okay, here velocity at 3/4 of maximum height here v is equal to u by 2. Okay, this is a final velocity of the body at O prime. Here initial velocity u, this is the initial velocity here u. The time taken to reach the O point here, time here at O prime, just O prime here, just t. Okay, t. Now according to first kinematic equation, v is equal to u plus at here. From first kinematic equation, v is equal to u plus at, the body moving upward direction, so the acceleration a is equal to just to minus g. Okay, now a is equal to minus g, here u is equal to initial velocity, v is equal to here v is equal to u by 2. Next, okay, this is time taken to reach the point O prime. Now these values here substituting, v nothing but here u by 2 at 3/4 of the maximum height. Okay, here u by 2 is equal to u here plus a is equal to minus g, into t and t. Now simplifies, here u by 2 is equal to u plus into minus, just minus gt simplifies, here u by 2, this is taken negative values taken right side, the positive values are taken right side, this one here taken left, this one here taken right, so that is equal to simply so gt is equal to u minus u by 2, u minus here u by 2. Okay, now here t is equal to u by 2g. Now according to the time of flight, the time of ascent to ta is equal to u by g. Here time of ascent to ta is equal to u by g, so that is equal to, here t is equal to u by g into 1/2. So this is a u by g, nothing but here time of ascent, that is equal to simplifies, here t is equal to ta by 2. This is the answer, this one here answer. So the time takes to reach the point O prime, that means the 3/4 of the maximum height, t is equal to the half of the time of ascent, t is equal to here ta by 2. Next condition, velocity up takes a time t is equal to ta into 1 minus 1/√2 to reach the half of the maximum height. First of all, the body to reach the 3/4 of the maximum height. Okay, yeah, this is a first case. Next case, note this one first of all. Okay, here next one, the body to reach the half of the maximum height, the velocity at half of the maximum height, v is equal to, here simply ground, here O is a half of the midpoint, half of the maximum height, here velocity at O is equal to, here v is equal to u by just √2, initial velocity u, u, and here a is equal to acceleration, a is equal to minus g, v means velocity at the half of the maximum height, u by √2. Now we find out the time taken to reach the half of the maximum height. Here velocity up, okay, the body project to upward direction, up takes a time t is equal to ta under ta into 1 minus 1/√2. So the time taken to the O point here, this is the just to t. Okay, here now first of all, velocity of at half of the that means here, okay, half of maximum height v is equal to just here u by root 2. Initial velocity u, here time of taken time at o to reach the time taken at time taken to reach the reach here half of the maximum height, half of the maximum height v is equal to, okay, t question mark here, just to t, okay. Now here values here, final velocity v is equal to u by g at o point u by root 2, a is equal to minus g, and initial velocity u. According to your formula, v is equal to u plus at. Now the final velocity at point to reach the half of the maximum height, that means here u by root 2 is equal to u into minus g just to t, just here t, simplies u by 2, this taken left side, okay, is equal to u plus into minus gt minus gt, okay, this is a root 2, sorry, this is a root 2, this one here root 2, okay. Here simplies gt is equal to u minus 1 u by root 2, this taken right side, this one here taken left, simplies gt is equal to, a u is a common term, so u is taken as a common, 1 minus here 1 minus 1 by root 2, 1 minus here 1 by root 2, so we want just to t, we want here t is equal to, simplies here t is equal to u by g into 1 minus 1 by root 2, here according to time of percent to ta is equal to u by g, so this is a u by g, nothing but here time of ascent, so simplies here t is equal to ta into just 1 minus 1 by root 2, this is a answer, this one here answer, okay, this one here answer. Once again, initial velocity u, the body projected vertically half, so acceleration is equal to minus g, here v means the half velocity of the body at the half of the maximum height, v is equal to u by root 2, so this value is here substituting, after finally we get here t is equal to ta into 1 minus 1 by root 2. Now ఇప్పుడు మనం ఏంటంటే the body drop from some height, freely falling body, okay, freely falling body. Now one body dropped one downward direction, another body here projected upward direction in the at the same time. సో ఒక వస్తువుని కొంత ఎత్తు నుండి జారవిడుస్తున్నా, ఇంకొక వస్తువుని అదే సమయంలో కింది నుండి పైకి విసిరివేస్తున్నాం. సో నౌ ఫైండ్ అవుట్ ద here at a time, okay, velocities are at a time, velocities are both are same. One question, the ratio of the displacements or distances and the time of the at the time, these are taken. Now three equations. Now after that the body dropped, okay, passing through the downward direction, the passing through 2 points, different points here A and B. The A and B separate some distances. Now find out the distance, time taken for the 2 points, cross the one point A, for example point B. Next the distance between 2 points. How to find out the formulas? Now first of all, this note this one first of all, okay. Here next the relation between maximum height and time of flight, the relation between maximum height and time of flight. So here simply the relation between time of flight time of flight and maximum height. Here maximum height, here h is equal to, here h is equal to gt square by 8. H is equal to here gt square by 8. How to this formula? Here the relation between maximum height, here time of flight, this is one here capital T, and maximum height here this one here h. Okay, the relation maximum height and time of flight. Now here h is equal to, formula h is equal to gt square by 8. Here g means acceleration due to gravity, t time, and this is a constant number. Okay, h is equal to gt square, g here capital T square. Okay, how to prove this one? Here first of all, the body projected vertically of initial velocity, just here initial velocity u, the point to reach the O point. For example, the body to reach the O point, that O point is a maximum height. The velocity of the body at the maximum height will be 0. That means here final velocity here 0. Okay, the height of this one, the path here just h, this is a h. So at a maximum height h, the time taken to the here time of flight, the body to reach the O point and come back to retest to point of projection, the total time here time of flight. That means here the sum of the time of ascent and the time of descent, that is equal to time of flight. So here maximum height is equal to simply u square by 2g. Okay, time of flight here t is equal to ta plus td is equal to 2u by g. Okay, now prove the relation here maximum height and time of flight, h is equal to gt square by 8. Okay, first of all this one here two methods simplify చేసుకోవచ్చు. ఎలా మనం రాసుకోవచ్చు ఒకసారి చూడండి. here maximum height h is equal to u square by 2g, here time of flight దీన్ని okay, time of flight t is equal to capital T is equal to here 2u by g. Okay, this equation for example 1, this equation 2, equation 2 squaring on both sides, equation 2 here squaring on both sides. That means here t square is equal to 4u square by g square, 4u square by g square. Okay, here one method, simply this one here take square on both sides, that means here t square is equal to simply 4u square by g square. Okay, this is a equation for example 3, this equation 3. Now equation 1 by 3, equation 1 h is equal to maximum height is equal to u square by 2g, equation 3 time square is equal to time of flight square is equal to 4u square by g square. So equation 1 by 3, after we will get here equation 1 means h. Okay, here h by equation 3 capital T square, nothing but here time of flight square is equal to here h values here u square by 2g by here t square values here 4u square by here just to g square. So this one here take this okay, now simplifies here h by t square is equal to simply 4u square here g square, and g square. Okay, next by here by 2g into 4u square, 4u square. Okay, simply here one terms here get cancel, u square get cancel, and g ones cancel. Now here this one cancel, g ones get cancel, so 2 4 ja 8. Okay, remaining here t, so simplifies here g by 8. So h by t square is equal to just h by t square is equal to here g by 8. So we want to the maximum height, h is equal to here simply maximum height is equal to this t square cross multiplication to the here g. So that means here g t square by 8. This is a one method, this one here one method. Okay, this is the one. Next, simply second method is very simple. Okay, note this one first of all. Second method very simple. Now here, according to time of flight, t is equal to 2u by g, 2u by g. Okay, simply this is a t is equal to u by g. Second method చూసుకున్నట్లయితే సింప్లీ ఎలా చేస్తున్నా, ఇక్కడ జస్ట్ క్రాస్ మల్టిప్లికేషన్ t gt by 2 is equal to just u. Okay, here u is equal to tg cross multiplication tg by 2. So this is a u. So u values here substituting. This values here substituting. So simply now h is equal to here time maximum height h is equal to u nothing but tg by 2. Okay, here tg by 2, sorry, tg by 2. Okay, here square by 2g by 2g. Okay, now 2g simplies h is equal to here t square g square by 4. Here this one here square, so t square g square by 4, t square g square by 4 here remaining here t square g square 2 to ja 4 to ja 8. Okay, 8g. Now here g term once get cancelled, g terms here once get cancelled, so gg get cancelled. Simplies here simply maximum height h is equal to here remaining terms t square and here g by remaining here denominator here 8. This is a next second method, very simple. Next, note this one, next continuation. Yeah, next these are concept oriented equations. Listen, body here, body A, the body A is reached from the top of a tower at the same instant body B is projected here velocity up. Okay, here three equations, three conditions. First condition, second, third one condition. Here first condition means here the height at which they meet is t is equal to h by u. Height at which they meet is t is equal to h by u. Here second case, the time after which their velocities are equal is t is equal to u by 2g. Show that the t is equal to h by u. Next, t is equal to u by 2g. Here third condition, the ratio of distances covered when the magnitudes of their velocities are equal is s1 is to s3. S1 is to s3 is equal to S1 is to s2. S1 is to s2 is equal to here 1 is to 3. Show that the three cases. First of all, this is a neat tower. The body dropped, the body A dropped from the tower. Okay, that means here initial velocity here is 0. Another body here B is projected up at the same time, that means simultaneously. Now these two bodies at any instant of the time t at point meet. Now find that t is equal to here h by u. Show that. Second one, the at a point at any instant of the time their velocities are equal, that means v1 is equal to v2. That means t is equal to 2u by g, u by 2g. Next, third case, the distances covered by the two bodies. Here s1 is to s2 is equal to 1 is to 3. These are show that the from equations. Now first of all, listen here, very simple. This is a surface, this one here surface. Now here this one tower, this is a here. Now just take imagination here, this is a tower. Okay, is a tower. The height of the tower here, for example here, height of the tower for example here h, height of the tower here just here h. Okay, h. here body A dropped, here body A, this is a body dropped downwards. Its initial velocity here, initial velocity 0, initial velocity here 0, velocity of the initial body A body. Next body B at the same time projected up, the same time projected up with initial velocity just u. Okay, another body for example projected up. Okay, another body here projected, this is a body B. Okay, now initial velocity here, this is a initial velocity just to u, initial velocity u. Now these two bodies meet at any instant, at any instant. For example, at any instant here t, first case here, first one answer, this body moving upward direction, this body moving downward direction, these two bodies meet. For example, here point O is a, these two bodies point at O point, for example at any instant t, at time here t. Okay, at time here t, at time t, at any instant time t, body B, body A meet at O point. Now the displacement of the body A, that means here the distance covered by the body A here, for example S1. Okay, this is S1 means the distance covered by the body A. Next, the body B, distance covered by the body B, for example this is one here S2. Okay, this is a S2. Okay, at time t, these two bodies at O point meet the at O point. అంటే ఈ B అనే పాయింట్ బాడీ, A అనే బాడీ రెండు కూడా మా O అనే బిందువు దగ్గర మనకి మీట్ అవుతున్నాయి. ఏ కాలం వద్ద, T అనే కాలం వద్ద మీట్ అవుతున్నాయి. ఓకే, నౌ ఫైండ్ అవుట్ ద T is equal to V prove the H by U. ఓకే, here H by U. First of all, here equation S is equal to V is equal to U plus here S. మనం we want here these two bodies at meet O point, the distance covered by the both bodies equal to here H, equal to H. Okay, these two bodies covered by the both bodies here equal to height of the tower, equal to height of the, that means here height of the tower, this is a height of the, so height of the tower is equal to here height of the first case here height of tower here H is equal to S1 plus here just S1 covered by the A body, S2 covered by the B body. Now this is a 1. Here displacement of the distance covered by the body A, here the body moving downwards, the initial velocity is 0, here A is equal to just to G and T is equal to just to T. Okay, T. Now here S is equal to distance, S is equal to ut plus of at square So here initial velocity substituting the, here this one body A. Okay, body A body. Now this one displacement here yes. Okay, here S is equal to just to S1 body A. Now here S1 is equal to U is equal to 0, T plus 1 by 2, A is equal to just G and T. Simplies S1 is equal to 0 plus half GT scale, that is equal to here 1 by 2 GT scale. So therefore here S1 is equal to half GT scale. This is the distance covered by the body A downward direction, here S1 is equal to half GT scale. Next, the body B, the distance covered by the body B to reach the O point at any instant here T. Now next, the body here body B, okay, body B, here A is equal to minus G, the body moving upward direction, so here displacement S is equal to just to S2, this one displacement S is equal to here S2. Okay, S2 and here velocity time here n of this one here n of here initial velocity U is equal to U. So S is equal to formula, second kinematic equation, S is equal to ut plus of GT square. So here S means S2, the distance covered by the body B is equal to, here U means U, here time same. Okay, plus of A is equal to minus G, A is equal to here minus G into T square into here t square. So simplifies here s2 is equal to ut plus into minus, just minus here of minus gt square, of minus gt square. This is a s2 displacement to the distance covered by the body b. So the total these distances of the both bodies, the distance covers by the both bodies is equal to here s1 is equal to s1 plus s2 is equal to just h height of the tower. So here this equation to this equation 1. Now here h is equal to s1 plus s2, s1 plus s2. This is okay, s1 plus s2. Equation 1 and equation 2 substituting. After we will get here t is equal to h by u. Okay. Now h is equal to s1, nothing but here. Sorry, this one not correct. This is the equation 1. Sorry, this is equation 1. Okay. Equation 1 of gt square plus, okay, plus. Now s2 is equal to ut minus of gt square, of gt square. So of gt square, this one here positive values, this one here negative values. So this terms here get cancelled, this terms here get cancelled. So remaining terms h is equal to height of the tower, h is equal to here just ut. So u means initial velocity of the body b. Okay, that means here h is equal to ut, that is equal to here t is equal to simply h by u. So the at any instant t, okay, the both bodies meet at a O point, the t is equal to the height of the tower by the initial velocity of the body b, initial velocity of the body b. This one first case. Okay, next case here, the time taken, the time after which their velocities are equal, is t is equal to u by g. T is equal to here u by g. Okay, note this one first of all. Now their velocities are here equal. Yet for example, the two bodies at O point, for example, at time instant of the time, at any instant of the time, at t, at O point, for example, its path, their paths here, this tower, this one here tower, okay, here at point at t, at any instant t time, both bodies meet at O point with the same velocity, For example, this is for example, O is a point, body b, body a. Okay, these bodies to meet the O point. For example, just to example, at time t, the velocity of the body, for example, at time t, here v1, body a, here v1, the velocity of the body b to reach the O point, for example, here v2. Okay, b2, body b2 to reach the O point with velocity v2, the body a to reach the point O with velocity v1 at time here t. Okay, now second case here, t is equal to u by, here t is equal to u by 2g. We prove the t is equal to u by g. Now here initial velocity of the first body, here u is equal to just to u is equal to 0. It initial velocity here u. Okay, initial velocity body b u. Now first case here, body a, okay, v is equal to u plus at, here at. Now here in this case here, the body moving downwards, here v is equal to here, u is equal to 0, v is equal to the point, the body a body to reach the O point అనే O అనే బిందువుని చేరినప్పుడు దాని యొక్క వేగము v is equal to v1. Okay, here time t is equal to t, here a is equal to just g, here g. These terms here substituting in here v1 u is equal to 0, here a is equal to g t. Okay, now v1 is equal to simply gt, this is our equation 1, this one here equation, for example, just 1. Okay, next body 2, here body b, here b. Okay, the initial velocity of the body u, the final velocity of the body to reach the point O here with velocity v2 velocity at time here t. Now here v is equal to v2, u is equal to just u, a is equal to the body moving upward direction, the body moving here upward direction, a is equal to g here, t is equal to as here, t is equal to just t. Okay, this is a case 2. Okay, now v is equal to formula, v is equal to u plus at, v is equal to here u plus at. So u is equal to u, a is equal to minus g, t is equal to t, here v is equal to just to v2. Okay, here v2 is equal to u plus minus g into t, minus g into t. Now here simplies v2 is equal to simply u here plus into minus gt. This is a velocity of the body b at O point to reach the point O point. So at O point at any instant t, their velocities are equal according to given condition ఇచ్చిన దత్తాంశం ప్రకారం the time after which their velocities are equal is t is equal to u by g. So here t is equal to question mark, t is equal to here 2 by u by 2g. Now this equation 1, this is a equation 2. Okay, equation 2 here according to given problem, given condition, their velocities are equal. So that means here equation here v1 is equal to v2, v1 is equal to here v2. So here v1 nothing but here to gt, okay, is equal to here v2 is equal to equation velocity of the body b, v2 is equal to here u minus gt, u minus here gt. Okay, now simplies here this taken as left side, this one taken as here left side, here u gt plus gt is equal to here just u, gt plus gt to gt, that is equal to here simplies to gt is equal to u. So we want just here t values. Okay, the at any instant of the time at O point t is equal to here t is equal to simplies very simple, t is equal to u by 2g, this is the answer. This one here second one answer. Okay, here second one t is equal to second one is here proved. Okay, ఏం లేదు ఇక్కడ ఇనిషియల్ వెలాసిటీ, ఫైనల్ వెలాసిటీ, here initial velocity u, final velocity second body v2. So equation apply the first kinematic equation. So v is equal to u plus at, at O point these two bodies moving at O point to reach the same velocity. So at any instant of the time t is equal to u by 2g. Okay, next case here, next condition, the ratio of distances covered when the magnitudes of their velocities are equal is s1 is to s2 is equal to 1 is to 3. Okay, note this one first of all. Okay, now third one, the ratio of distance covered by the two bodies s1 is to s3. Okay, here their velocities are here equal, this one same, this is a tower, this one here tower. Okay, here these two bodies O point meet the O point here at time t here velocities are v1 is equal to just to v2 according to given condition. Velocity at O point here equals. Okay, the distance covered by the first body, a body, this one here body a, the distance covered by the here s1 a body. Next, the distance covered by the body b, this is one here body b. Okay, this is s2. The distance covered by the body a s1, the distance covered by the body b here is s2. Now the ratio of their distance here s1 is to s2 is equal to 1 is to 3. We prove this 1 is to here 3. Here condition, given condition at O point their velocities are equal at O point. అంటే O అనే బిందువు దగ్గర అవి రెండు చేరినప్పుడు వాటి యొక్క వేగాలు అనేటివి సమానంగా ఉన్నాయి. కాబట్టి అకార్డింగ్ టు సెకండ్ ఈక్వేషన్ ద వెలాసిటీస్ ఆర్ ఈక్వల్, దెన్ ద టైమ్ t is equal to u by 2g. Okay, now here v1 is equal to v1 is equal to v2 that is equal to u by 2. now ఇంతకు ముందే దీన్ని మనం ప్రూఫ్ చేసాం. ఓకేనా, ఎట్ మిడ్ పాయింట్ ఎట్ O పాయింట్. ఓకే, v1 is equal to v2 that is equal to here u by, this is a t is equal to u by 2g, this is a condition. Now the distance covered by the body A, now here distance covered by body A is here S1 is equal to formula S is equal to ut plus half at scale. S is equal to here, S is equal to S nothing but S1 ut plus half at square. So here A is equal to G, A is equal to G, here U is equal to just to here 0. That means here initial velocity of the body A, freely falling body, this is A body is a freely falling dropped body. Okay, initial velocity. So these are substituting here S1 is equal to 0 into t plus of gt square. So simplifies S1 is equal to here S1 is equal to remaining of gt square. డైరెక్ట్ స్టెప్ వేయొచ్చు, కాకపోతే కాన్సెప్ట్ కోసం చెప్తున్నా. S1 is equal to half gt square. Now this is a equation. Now according to their velocities are equal at O point. At any instant here t v1 is equal to v2. So v1 is equal to v2 that is equal to t is equal to u by 2g. This is a okay. Now this t values here substituting here simply. Okay, here t is equal to u by 2g, t is equal to u by g. So this is a substituting here S1 is equal to half g into u by 2g, here t square nothing but whole square. So S1 is equal to half g u square 2 2 ja 4 here minus g అంటే g square. So g into u square by 4 g square, u square by 4 g square. So here once get cancelled, g once get cancelled, remaining terms u square by 2 4 ja 8. So here S1 is equal to u square by 4g. Okay, u square by g once get cancelled, remaining g. So here u square by 8g. This one here equation 1. This is a equation 1. Okay, here S1 displacement to the distance covered by the body A to reach the O point at any instant here t. S1 is equal to here simply u square by 8g, okay. This one next the body to reach the O point, body B to reach the O point, here distance covered by the here S2, now note this one first of all. Okay, now here the distance covered by the body B, the distance covered by the body B, equation of రాసిన S1 is equal to u square by 8g, now the distance covered by body here body B is here S2, okay. Yeah, initial velocity u here. Next a time t, a displacement here S2. Okay, here A is equal to the body moving upward direction, so A is equal to minus g. Here S is equal to S2. Initial velocity u is equal to u. Okay, here final velocity we don't know this one here. Okay, now according to second kinematic equation, so here S is equal to ut plus of 80 square. So these are substituting here. S means S2, simplies is equal to u t plus of to minus g t square, minus g t square. So here S2 is equal to ut plus into minus, here plus into minus, minus of gt square. Now here t is equal to u by 2g, t is equal to here, t is equal to u by 2g. Okay, t is equal to u by 2g. So t values here substituting, simplies S2 is equal to u into u by 2g minus 1 by 2 into, here t means u by 2g square. This term here, that u square by 8g. Now u into u square by 2g, u square by 2g. This total terms remaining here simplies u square 4 g square g get cancel, remaining here minus here u square by 2 2 ja 4, 4 2 ja 8. Okay, g once get cancel, so g, u square is common term, g is common term of, so simply LCM, simply here S2 is equal to, here simplies S2 is equal to u square by 2g common. Okay, u square by 2g. Now here remaining 1 minus 1 by 4, 2 2 ja 4. Okay, remaining. Now this one LCM, 4 1 ja 4, 4 minus 1, so 3 by 4. Now simplies S2 is equal to 3 u square by, simply 4 1 ja 4, 4 minus 1, 4 minus 1 3 by 4, 3 by 4 into u square by 2g. So 4 2 ja 8, 8g, 3 into u, 3 u square by 8g, 3 u square by 8g. So this is a equation for example 2. So equation, so S2 is equal to 3 u square by 8g, 3 u square by 8g. Okay, the distance covered by the body B, S2 is equal to 3 u square by 8g. The distance covered by the body A to reach the point to O, here S1 is equal to u square by 2g. So the ratio of the distance covered by the both bodies. So therefore the ratio of their bodies, okay, their distance, the ratio of their distance covered, the ratio of distance covered both bodies, the ratio of distances covered by the both bodies are S1 is to S2, S1 is to here S2. So here S1 means here u square by 8g, okay, by, that means here S1 is to S2, nothing but here S1 by S2. Okay, S1 by S2. So here u square by 3 S2 means here 3 u square by simply 8g. Okay, this one here, this one. Okay, here 8g get cancel, 8g get cancel, 3 u square, 3 u square. One step, note this one first of all, note this one here, simplies S1 is to S2 is equal to u square by 8g by here 3 u square. So here 8g get cancel, u square get cancel. So simplies here S1 is to S2 is equal to here 1 by 3, that is equal to here simply S1 is to simply S2 is equal to 1 is to 3. Okay, this is the answer. Next class, okay, note this one. Okay, note this one. Okay, now next class continuation. నెక్స్ట్ క్లాస్లో మనం ఏం చేద్దామంటే ద బాడీ, ఎక్కువ టైం చెప్తే పిల్లలు చూడరు, the body here passes through the 2 points. Freely falling body passes through the 2 points. Okay. For example, point A, point B. The distance covered by the two bodies in between 2 points. The time taken by the in between passing through the 2 points. అంటే ఏ అనే బిందువు నుంచి ఒక కొంత హైట్ నుంచి కింది జారినప్పుడు రెండు బిందువుల మధ్య దూరము క్రాస్ అయినప్పుడు ఆ దూరం మధ్య ఎంత టైం పడుతుందో అనేది ఆ రెండు బిందువులను దాటడానికి పట్టే కాలము, వాటి మధ్య దూరము, వాటి యొక్క నిష్పత్తి, రేషియో ఎక్సెట్రా డిస్కస్ చేద్దాం. ఓకే, చూడండి, సబ్స్క్రైబ్ చేసుకోండి, వీలైతే మీ ఫ్రెండ్స్కి షేర్ చేయండి. ఓకే, థ్యాంక్ యూ, ఆల్ ది బెస్ట్.